Hello students. Today I'm going to solve some problems from GATE 2025 question paper. The topic is classical mechanics. So let us see some questions. Now this is question number 38, and here you have been given a spring mass system and they're asking the frequencies of the normal mode. Okay, so let us approach this question. So now I say that this mass m is given a displacement x1 and this mass is given displacement x2. So I can write now the kinetic energy T, which will be half m x1 dot square plus half m x2 dot square. Similarly, if I write the potential energy now, so potential energy will be what? Potential energy will be for this spring will be half k1 x1 square. Similarly, for this spring it will be half k x2 square. And I write for middle one, so this will be half k x2 minus x1 square. Okay, so these are the expression for kinetic energy and potential energy. Now let us write the matrix element. So say so I can write the potential energy, this V, as half k1 plus k2 x1 square. K2 is coming from here, K2 x1 square coming from here. Similarly, plus half K1 plus K2 x2 square. And if I solve this one, this will give me simply 2 cancel. So K2 x1 x2. So from here, now I can write the matrix element for V. So V11 will be simply K1 plus K2. Now K1 is given 2, K2 is 3, so this become 5. B12 is minus K2, K2 is 3, so this become minus 3. V21 is also minus K2 is minus 3. And now if I write V, this V22, so V22 will be again K1 plus K2 equals to 5. Okay, so now we have these things. Now we can write matrix element for kinetic energy also, and this for mass. So from here I can write m11 is m is 1, so 1, m12 is 0, m21 is 0, and m22 is again 1. Now let us solve the determinant V minus omega square t or g equals to 0. Okay, so this gives me V is 5 minus omega square, m is 1. Okay, and then you have similarly minus 3, 5 minus omega square equals to 0. Okay, now let us solve this problem finally. So this gives me, if I solve this one, this gives me 5 minus omega square whole square minus 9 equals to 0. And this gives me 5 minus omega square 9. So 5 minus omega square is plus minus 3. So omega square is 5 plus minus 3. So this gives me omega 5 minus 3, 2 root 2, and 5 plus 3, 8 root 8. So the option A, okay, option A is the correct answer for this question. So let us go for now second questions. Say, so this second question is also from Lagrangian Hamiltonian mechanics. So Lagrangian is given. Okay, so Lagrangian is given to us. So Lagrangian L is what? Lagrangian L is your half m v vx square plus vy square plus vz square, and then you have this qb x vy and minus plus, here I can write plus qbx minus qby vx. Okay, this is my Lagrangian. Now I can find the conjugate momentas. So conjugate momentas will be uh, say this is px. So px will be del upon del vx. So this will be what? This will be, if I differentiate, this will be mbx. Okay, mbx, and vx is here, so minus qby. Okay. Similarly, if I write for py del upon del vy, okay, so this will be mvy. This will be plus qbx. Okay, and now I can write for same for pz also. So pz will be simply mvz. Okay, now you have to solve this one for Hamiltonian. So say Hamiltonian. So now I can write, we have px py value, so I can write now, I can solve for this vx. Okay, so my vx will be 1 by m px plus qby. Similarly, vy will be 1 by m py minus qbx. And now if I write vz, so vz is simply pz upon m. So now I have vx also. Now we can write the Hamiltonian. Okay, so Hamiltonian क्या हो जाएगा? Hamiltonian will be h. Okay, that will be px vx py vy pz vz minus l. So I can write now value of px. Okay, we have px values. So h will be px क्या हो जाएगा? Px is your mvx minus qby into vx plus py value is mvy velocity qbx vy. Okay, and then you have a pz vz, and then you have finally l. Okay, now we can solve this one. Okay, so this will give me h m vx square minus qby vx plus m vy square plus qbx vy, and then you have a pz. Okay, so pz, I can write what? If I write pz value, I did not replace here bz. So pz is basically vz, so this become mvz square, and now you have a Lagrangian. Okay, Lagrangian is equal to minus half Vx square, Vy square, Vz square, and then you have also minus q b x Vy, and then minus minus plus q b y Vx. Okay, so we have now the values in terms of Vx. Okay, so I can erase this one. So I have now Hamiltonian H is half mvx square minus half mv square. So this will give me half m vx square. Similarly, it will be half m vy square, and this will be half m vz square. And now this term, this is a plus Vy, this is a minus Vy, this is a plus Vx, this is a minus Vx. This will be cancelled out. Okay. So now just put the value of velocity in terms of momentum. So this will be now, if I put the value of here, so this will be 1 upon 2m. Vx is here, px plus q by square plus py minus qbx square, and vz is simply pz square by m, moment is there, so pz square. So this is the my Hamiltonian expression, and this is given as a option D. So option D आपका सही हो गया. Option D is the correct answer for this question. Now let us check about whether other options are matching or not. So we have to now solve the other options. Okay. So first option is dx by dt, that is x dot dx by dt. Okay. So Hamilton equation says del x by del t is equal to del h by del vx. So now if I differentiate with respect to vx, this Hamiltonian, okay, so what I'll get? I want x px. So if I differentiate this one, so dx by dt. So where is px? Here is a px. Okay, so this gives me 1 by m px plus qby, and this will be 0, this will be 0, px1. So this shows px plus qby, but here this, if you see the options carefully, there's a minus is there, so this option is not matching. Okay, now let us find out del px px dot, which is dpx by dt, and Hamilton equation says this is equal to minus del h upon what? Px is there, so this will be x. Okay, so let us solve for this one now. So this gives me px dot, this gives me minus, so x is not here, x is here, only here, so we have to see only this term. So this gives me py minus qbx power 2, 1 by m will come. Okay, and then I have to differentiate this one. So this will give me minus qb, so this will become plus, and this will become qb. So qb by m, py minus qbx, qb by m, py minus qbx. So this option is matching. So this option is correct. So this option, now see the last option, third option. So third option, say py. So d py upon dt, which is again equal to minus del h upon del y. So this will be minus, we have to differentiate only this y term. So this will be 1 by m px plus qb y, and now qb will come also. So minus qb by m px plus qby. So option C is also matching. So B, C, D are the correct. Okay, only A is not matching. Okay. So let us, this was second question. Now let us go for the third question. So the third question is also from Lagrangian. So Lagrangian Hamiltonian, sorry. So what this says, see, bead is constrained to move along a rod, massless rod, okay, in the z direction. So you have, so let us understand the system. You have, this is your z axis, this is your x axis. A rod is placed parallel to x, okay. So this remain horizontal, okay, and your bead is moving parallel to the x-axis, okay. So bead is moving, this is your bead, is moving like this is the mass m, okay. So now we have to find, and it is given this rod is also moving with a constant velocity. I say this velocity is vz, okay. So obviously if rod is moving, okay, against the gravity, so Hamiltonian cannot be the uh, conserved. Hamlet cannot be conserved because already you have giving some force, okay. You're supplying some energy, so this rod cannot go automatically upwards. So what you're basically doing, you are applying some machine which is lifting this rod up. So Hamiltonian cannot account for that external energy. So let us solve this one. So say, now I have to write first the Lagrangian for this problem. Okay, so Lagrangian would be what? Lagrangian will be, say, your L half m x dot square, because x is varying for bead and z is also varying for the bead. So that is z dot square. Okay, and now if I write the, if I take the potential is 0 here, so this distance is, say, z. So my potential will be minus mgz. Now the system is moving with constant velocity. Okay, system is moving with a constant velocity. So I say my z will be simply vz, velocity I have to vz into t, and my z dot will be simply a constant vz. Okay, so if I put these values here, the L, my L becomes half m x dot square, z dot will be simply vz square constant, and minus mg vzt. Okay, so now the Lagrangian contain a term which explicitly depends on the time, so your Hamiltonian cannot be conserved. Okay, now let us find the Hamiltonian. For that, first we have to write, say, px conjugate momenta del upon del x dot. So this will be simply mx dot, and now you have pz. Pz is del upon del z dot. Now z dot is constant. Okay, so this will be 0. So I can now write the Hamiltonian for the problem. So Hamiltonian will be simply px, okay, ps x dot plus pz z dot minus L. So px is your m, x dot is square, this is 0. L is again minus half x dot square plus z dot square, and sorry, vz square, this is constant vz square, and this is minus minus plus mgvzt. So if I solve this one further, so this gives me what? H is equal to half m x dot square minus half m vz square and plus mg vzt. So your time is there. Okay. So obviously this is expression is not equal to the energy. Okay. This is not equal to the energy. This expression is not equal to the energy. So what I can say? I can say that H is not conserved because you are providing because L depends explicitly on T, you are providing the external energy which H cannot account and is not equal to total energy. So the option D seems to be correct. So H is not total energy of the system and H is not conserved. Okay. So hope you understand the question. Now let us go for the next question. So next question. So this question is from the relativistic expressions of Hamiltonian and Lagrangian. So you have been given a relativistic particle or rest mass m, okay, moving in the x-axis, and its Hamiltonian is given by T plus Vx. Okay, so T is the relativistic energy and kinetic energy. So what I can write here, I can write H. So H is simply okay. So H I can write okay relativistic energy, which is P squared C square M0 squared C4, and then you have a Vx. This will be Vx. Okay, and I can directly solve this one. H is equal to, so H will be what? H will be, if I take C square common here, so this will be M, I'm writing M not M0, M square. C4 is common, so this become M square, and this is P square divided by C4 C square plus Vx. Okay, so this is already given, option A, option A. So option A is the correct. Okay, now let us find out the Lagrangian, and before we find out the Lagrangian, let us find out x dot, that is V, x dot, that is V, which is equal to what? Del H upon del P. Okay, so let me differentiate this H. Okay, so this gives me what? V equals to, if I differentiate this expression whole, so this gives me under root 2 P square C square M square C4, and if I differentiate P square, so this will give me 2P C square. Okay, so 2 cancel, so this gives me PC square. And now if I take, this is PC square, if I take C square common from here, C square, so C will come out, and this will be P square plus M square C square. Okay, C cancel. So this is the expression for the velocity. So the option B is also correct. PC upon P square plus M square plus C. Okay. Now let us go for the Lagrangian. Okay. So Lagrangian is what? Lagrangian is L. I can write because you know the Hamiltonian H. Hamiltonian H is what? PV minus L. From here I can find the L is PV minus H. So P value already B value we have already. So you can put the value here. So this gives me P square. Okay, I'm using this V. So V is C square. Okay, so I can directly P square C. I'm using this expression C square P square C square M square C4. Okay, this become PB, and now H. So H is again this one P square C square M square C4. Okay, plus Vx. So this become minus Vx. Now we can solve this one. So this gives me P square C square. Okay, this gives me minus P square C square minus M square C4 upon P square C square M square C4 minus Bx. Okay, and now I can simplify it further. Okay, now this expression. Okay, so this cancels out. So I have L is equal to minus MC square M square C4, and then you have this is P square C square M square C4 minus Vx. Okay, now I can make it simpler. If I put the value of P from this equation to this equation, okay, I can show you, we can easily prove that P square, this expression P square C square M square C4 is nothing is equal to MC square 1 minus B square by C square. If I put the value of P from this expression to this equation, I can bring in terms of this expression in terms of V, eliminating P. Okay, I can eliminate P here. I can put the value of P in terms of V here, and I can solve this one. So this will give me this one. And now I can, once I have this one, I can write the Lagrangian L minus M square C4 divided by MC square multiplied by 1 B square by C square minus Vx. Okay, so M cancel, C cancel, so L comes out minus MC square 1 minus B square C square minus Vx. So this is option D. So option D is also correct for this question. Okay, so now let us see some more questions. So let us see this question now. So you have here Hamiltonian is given P square upon 2m plus Q square AQ. Okay. Now what I can do, I can write the equations, Hamilton equations. I can write, say, Q dot will be del H upon, okay, X dot del P. And similarly, if I want to write, say, P dot, that will be del H upon del Q minus, okay. So first let me write the Q dot. So Q dot will be simply P by M, okay, P by M, and this will be what? This will be, if I differentiate with respect to Q, so Q is 2Q minus 2Q AQ minus 2Q AQ, and the next time if I put a here minus Q square as it is, I can write del AQ upon del Q. And this equation gives me P dot equals to M Q double dot, that is M d2q by dt square. Okay, and this value is already given minus 5q AQ. So this equation will be minus 5q AQ will be minus 2q aq minus q square del aq upon del q. So q cancels, okay? 5q aq. So q cancels, one q is here, minus sign also cancels. So you have only here 5 aq, okay? And this is plus, now become plus minus 2 aq. And here you have q del aq by del q, okay? And now if you solve this one, what should it give? This gives me 3, okay? 3aq is equal to q del aq upon del q. And now we can simplify it further. So this becomes 3aq by q here, okay? And this remains only del aq upon del q. So this is the expression, and here n value is 3, okay? So the n value is 3 for this question, okay? So let us see one more question. So here question says that you have been given a canonical transformation, okay? Now, which of the functions are the generative functions for this canonical transformation? So you can do it in two way. You can assume these generative functions are correct and you try to get this expressions back, okay? I'm going to do other way. I'm going to calculate. I know I am assuming I have the canonical transformation. I will calculate the f1. You can do other way. You can assume the function and prove this one. So let us